Okay, so this lesson is about percentiles, IQR, and box plots, and hopefully you already did your notes. There were some interesting things here with the SAT. And we did have a slightly different definition of percentile here where we said below. I'm going to actually go ahead and edit this to match what our activity does. There are two definitions for percentile. It's the number of data points at or below the value divided by the total. So you can see different percentiles here. Here we used below. But let's go ahead. And then our goal is to make a box and whisker plot. And the low end of the whisker tends to be the minimum unless you have outliers. So I should probably add a note there. Let me add a note while we're thinking. So the max and the min, let me go ahead. Max and min tend to be at the end of the whiskers unless there are outliers, and those become your maxes and mins. So that's probably a good thing to add because that's one of the common mistakes that happens. So anyways, we talk you through how to do a box plot, and actually the easiest way to do it is just do it on Statplet. Okay, but there are some calculations we're going to do by hand, so Statplet won't do everything for you today. All right, so the topic today is we're going to look at tax cuts. So a lot of times when tax cuts are put forth, you tend to have people who oppose it, people who favor it. And there's the 2017 tax cut that President Trump did back in his first term in office, and I'm actually recording this shortly after the 2024 election. And people say that it's probably, that it came down to the economy and they were hoping for more tax cuts and, just more money. And so they were hoping that Trump would be the choice they did. So that's what I've been reading in the news. So that could be why he won. Who knows? So by eliminating tax breaks and loopholes, we will ensure that the benefits are focused on the middle class, the working men and women, not the highest income earners. Now, the other side of this is that a lot of people, like Bernie Sanders down here, you remember just a few years ago when Trump and my Republican colleagues voted for almost $2 trillion in tax breaks for the wealthiest people in this country and the largest corporations. So the question is, are tax cuts really benefiting the wealthy, or is it really benefiting the middle class? We're going to look at both of those statements using a box plot. So, but before we do that, let's go ahead and practice with box plots. So let's start with the salaries. And this is the salaries for 8 people. Now, obviously, I've already worked through this. And you can get a link to the work in the Kami so you can copy it down more easily. So we have a bunch of salaries, and they ask us to find the median. And you find the median by cutting the data in half, which was right here. So there are 8 data points. And I'm sorry, not 8, 12 data points. And so the first 6 is in the first half. The second 6 is in the second half. There's no actual data point right in the middle. So we will go ahead and take the average between the two ends here, the high end of the first half and the low end of the back half. So adding those up and dividing by 2, we get 34.5. So our median is 34.5. Now we need to find quartiles. So what you're going to do is take the first half of data and cut it in half. Well, what's number is halfway between 34 and 34? Or is the average of 34 and 34? It's 34. And so we call that Q1, all right? And here is, we cut the top part of the data in half. And so the midpoint is somewhere between 39 and 40, so we average those, and we get 41. So we write down the boundaries. We look at each piece. We've got this piece, this piece, this piece, and that piece, 4 pieces. And we write the boundary. So we got 29 is at the low end. So don't ignore the beginning. Then 34, then 34.5, then 41, and then the high is 185. So this is called our 5-number summary. It's min Q1 median, Q3, and max. So use the definition of percentile as, and notice they're telling you which definition to use because there's actually more than one running around. Good news is we're not going to give you a question where you're like, oh, which one am I supposed to use? Okay. So use the definition of percentile, which is percent of data at or below the value, to answer the following. What is a percentile for the min? Well, you would have, it's the lowest data point, so there's only one, out of 12. Divide that on your calculator, you get 0.0833. So this becomes 8.3%, and percentile we tend to round to the nearest integer. So it's the 8th percentile. I mean, you could probably do decimal, but most people say integer. Okay. Then quartile, what is quartile? That means we're going to take a quarter of the points, or at or below, and 3 out of 12 is 0.25, or 25%, 25th percentile. And when you think about it, think of a quarter, right? So think of 25 cents. Let me do a little side note. Think of 25 cents. Oops, let me do a symbol. Is there a penny symbol? I'll just write cents, right? That's a quarter, and it's a quarter of a dollar. All right, so that kind of helps you think quarter. So let me highlight that right there. All right. What is the percentile for the median? It's the 50th percentile because you have half the data at or below. Q3, you have 3/4 of the data at or below, so 75th percentile. The max is always at the 100th percentile. Okay, and then so we're going to draw preliminary box plots where we at those numbers. So you put the box around the middle set of data, all right? So the box covers the middle set of data, and then you cut it in half, where you have some data points in front, some data points in back, and then IQR is the width of this box. So the definition is Q3 minus Q1. So it's 41 minus 34, which is 7. All right. So now that box is just with all the numbers listed. If we put the numbers to scale, I can't actually, here, let me go ahead. The 34 goes right there. The 34 point, no, I'm sorry. Let me undo that. The 34, it's kind of tight. Actually, I might just edit this. Let's do this. I'm going to alternate these numbers so I can actually type them a little bit better. Go back to blue. So the 34 is on the edge of this box plot. Box plot. So if I were to draw 29, actually I can probably space out 29 a little bit. I'm just trying to make sure this makes a little bit of sense to you guys, okay? There we go. Let's put that so it's a little closer to the numbers, and then I'm going to put the 41 down here just so it makes a little more sense. So 34 and 41 are Q1 and Q3. Let me push the 185 back out to where it belongs. Oh, that's about right. Okay, so let's draw little arrows because we got a lot going on in this little box. There's 29. 34 is right here. 34.5 is right there. And that's 41. Okay? So it's the same values it was here. It was 34, 34.5, 41. But because I didn't have them to scale, it wasn't so hard to arrange all this. Okay. Now, outliers is a big part of doing box plot. Outliers are unusually high or low values that are far away from the middle 50% of data. And so do any of the values look like outliers? This one for sure. When I was doing this lesson in class, we're like, well, maybe this one. So you've seen the punchline. Yes, this one is an outlier. So how do we know that one's an outlier, but not this one near 40, right? Because there is a gap. Just having a gap doesn't mean it's an outlier. So let me add that as a nice little note. Just because there's a gap doesn't mean it's an outlier. Okay? So we have to confirm it mathematically, okay? So all points between boundaries. So what we're grading is a lower boundary, and let me kind of highlight that there. So we have our lower boundary here, right? This is our lower boundary. And let me do a different color. I'll do orange. This is our upper boundary. It's right here. See that? So all points between the boundaries are not outliers. I actually like this better. And put that back. Yes, you're seeing this as everyone. Modify. I'm just trying to make it better. Just trying to make it better. So anything in there is not an outlier. So these two will be outliers. They're outside of the boundaries. But how do we calculate that? There is a formula. So you want to put this box on your cheat sheet. All right. So put this on cheat sheet. Cheat sheet. Let's put this in red. Cheat sheet. All right. Some of you are like struggled to find something. What should I write? I already know everything. And you may memorize this pretty easily, actually. Put that on your cheat sheet. Okay. So there is a mathematical method. And what we say is if this width of the box we call IQR, right? And if you're more than 1.5 widths outside of the box, then you're like, oh, you're really outside the box. So we call you an outlier. All right, so first of all, I brought back my IQR 7. In case you forgot, we calculated it right there on the previous page. Okay, so IQR, upper limit and lower limit, need to be done by hand. Everything else can be done by Stapplet. Okay, so the upper limit, the biggest mistake people make on this, I'll just do this in yellow, is they mix up the signs. One of these is a plus. One of these is a minus. So remember, for the upper limit, you're trying to go higher, so you're adding. For the lower limit, you're trying to go lower, so you're subtracting. So that's typically the mistake that I see. The other mistake I saw while working with students, some students wanted to add the 41 and the 1.5 and then multiply by 7. You need to multiply this first. So multiply that part first. Let's just add a little down. IQR 1.5 first before adding. So this is what I saw with my classes. Is that was some people were getting like 200 and some. And I'm like, what's going on? Oh, they were adding the 41 and the 1.5, then multiplying by it. Not a lot of people, but enough that I was like, okay, I better address this. So here we go, 1.5 times 7 plus 41. Your calculator should spit out 51.5. And then for the lower one, remember we're subtracting now, but multiply the 1.5 and the 7 first. And subtract that from 34, and you should get 23.5. Yeah, when you multiply these two together, you should get 10.5. So it's 41 plus 10.5, 34 minus 10.5. By the way, if you plug this in the calculator exactly as it is in a good format. It will spit out the right answer. Now, let me show you the box plot. Oops, I forgot to get the data. So I'm good. I'm going to go ahead and do a Stapplet. So let's show you how to do this. All right, so let me get this data that we have, and I'm just going to type in one quantitative variable single group is what you want. All right, and we're going to do 29, 32, 34. There should be 4 34s. 35, 35, 39, 43, 67, and 185. This one's salaries. I like to put a thing on it. And then you hit begin analysis. Let's make sure it looks right. Looks good. And let me just double check one other thing. I always like to look. If I know the answer, this is one way. If this, oh, I think I missed. Oh, it's just the decimals. 12, yeah, we're all good. All right. So, a cool way to get your box plot, and the way I like to show it is by clicking this. Because I could do box plots separate. And it works. It's fine. But for right now, I want to do dot plot and show you the box plot. Why? Because then I can show you where the pieces come from. So when we did our math, we said the upper the boundary was 51.5, right? So if I go to the data, 51.5 is here, but you don't see the whisker going to 51.5. It's just the boundary for when something becomes an outlier. So everything to the right here, see this point at 60-some, 67, and 185? These are both outliers, all right? Then the highest data point that is not an outlier, that's the end of the whisker, all right? So here, this is the lowest data point, but if you look at our calculation, and I have this box plot here, we didn't have any low outliers because the low value is 23.5 and the min was 29. So everything was higher than the low outlier boundary. So this boundary was below all the data. And so this whisker on the bottom goes all the way to the min. This whisker does not make it to the max because we've got some outliers. So the max is actually out here. Okay? Describe the box plot. Use the median instead of mean because of skew. So because we do have this skew, anytime you got an outlier, use the median, period, okay? Just use the median. And it is skewed to the right, so it's stretched out to the right. Use IQR. So IQR is like the median of spread, so don't use standard deviation because we do have some other values. There's standard deviation. And you're going, but IQR is not on the Stafflet. Well, subtract Q3 minus Q1. And then the outliers should be auto-identified for you on the Stafflet. In fact, if you float over them, you can see their values right there, okay? All right. Now, just back to, we're going to skip in terms of writing, but I'll go ahead and discuss this. So, and it was interesting discussing it with my class. So we're looking at two types of tax cuts, Plan A and Plan B, and these are the box plots. And I asked the question, if you're like in the upper half of incomes, or let's say the upper part of incomes, you're rich, all right? Which tax cut would you like best? Well, if you're rich on Plan A, you would be over here, right? So, and let me go ahead and highlight it. So rich people are over here. But if you're rich on this plan, you're over here. So rich people would like Plan B better because there's more options. Because higher max, right? And a tax cut is usually out of money you're already paying taxes on. So people who are paying, to get a $7,000 tax cut, you probably have to be paying a lot more than $7,000. So that's also part of the reason the rich people are on this end. Now, let's say you're middle class, all right? And if you were middle class, let me do a different color. We'll do green, all right? Middle class, let's say we'll use the median, right? Oh, it's yellow anyways. Here we go. We'll use the median. So that's what your typical tax cut would be. But over here, your tax cut would be here. So your middle class would definitely prefer Plan A, right? And that is typically what they're talking about. Honestly, a lot of tax cuts do look a lot like this Plan B. Not saying it's a horrible thing. So, in fact, let's look at the actual data from the last tax cut. And you can see this table shows actual tax cuts of the Americans. And so there are two statements here, and both of these are misleading. All right, because remember, both sides are trying to get at their own end. So always take everything they say with a grain of salt. Basically, they said only the wealthy benefited from the 2017 tax reform. The middle class didn't benefit at all. So here, that's the middle class, all right? And did they really not benefit? Well, I don't know about you, but if somebody gave me $780 back, I would not be complaining. That's a car payment, right? And not a bad car payment. So, well, I mean, it's a decent car payment, I should say. So, misleading because middle class, 20%, got 700, pretend I can type. What's going on here? Got, there we go. Oh, Mrs. Overman. $780 typically got $780 back. Nothing to sneeze at, especially if you're middle class, right? If you're rich, maybe $780 isn't so impressive. Now, this other statement said, oh, the typical American household paid $1,260 less in taxes. So they did the average. But we got to remember that this data is skewed, right? So it pulls to the right. And so basically it's not the best descriptor. So because the data is skewed, really the more typical tax cut average is not a good measure. The more typical tax cut, the median, is a better measure. And it's less at, I wanted to say only, but I don't really want to knock a $780 tax cut. That's one car payment. And we'll skip the big ideas today. We got them already. Honestly, you've got your quartiles. You got this piece right here. That's honestly, I'd just have you rewrite some of that. And that's it for this part of the activity.